Actually, limit plays a very important and dominant role in the concept of calculus. When suppose at x equal to c, we cannot get the value of fc, fx a function given. Suppose this is a function, I am writing the function, fx is a function like this, sin x by x, this is a function fx. At x equal to 0, you cannot get its value because it is of the form 0 by 0. 0 by 0 is not infinity at all, it is undetermined, value cannot be determined. So, it takes the value 0 by 0, but if you take limiting value of it, it will be 1. And sometimes we have seen in the practical application that limiting value plays a very important role when the actual value cannot be determined. So, let us consider here one very typical example. Suppose x is any variable or any quantity and its value is 2.01, 2.001 etc. And another quantity x also that takes the values, suppose these two x are different, you may write y also, it takes the value 2, 1.9, 1.99 and etc. If you look at the two values of x and y, you see in the first case the values of x gradually increases, but it tends to 2. It never exceeds, it is in the vicinity of the number 2 or in the neighborhood of the number 2. And in the second case also y tends to 2, but y here y is in the vicinity of 2 no doubt. In both the cases we write x minus 2, if it is x again, x minus 2 is less than epsilon. Epsilon is a pre-assigned positive number in each and every case. Here 2, here also 2, in both the cases we may write x mod x minus 2 less than epsilon. Epsilon is a pre-assigned positive number. If you can write this, then the limiting value of x is equal to 2. So, sometimes the limiting value will replace the actual value when the actual value cannot be determined. Just like we have given one example and there are more examples also. And from your plus 2 stage, you are reading limit. So, you are familiar with the formula which controls limit. I am not discussing here the formula because we take it granted that our viewers and listeners know the basic concept of limit. So, we consider the first problem. The first problem is a very tricky problem because we know usually without just thinking over the problem, some student may write the answer as 1 because they know limit x tends to 0 sin x by x equal to 1. But you should know one thing, that in that case that x should be in the circular measure, that means in radian. Here x is given in the degrees, actually intentionally it is given. So, you have to first convert this degree to the corresponding circular measure, that means radian, and the conversion is, you know, perhaps 1 degree equal to pi by 180 circular. Radian is written like this, c circular measure. So, this problem is like this, limit x tends to 0 sin x degree. So, sin pi x by 180 by x, I am writing x as pi x by 180 into pi by 180. This is a question of 1 mark. So, the calculation will not be lengthy, into pi by 180, and this limit is 1. Suppose this is y, sin y by y, this limit is 1. So, the answer will be pi by 180. Though without any thinking, some can write the answer as 1, some can select the answer as 1. The second problem is also a question of 1 mark, where instead of x tends to 0, we have written x tends to infinity. So, you cannot write it as 1 readily, because if x tends to 0, that is 1, but you cannot write as 1 as x tends to infinity. remember one thing, when x tends to infinity in each and every problem, you will write x equal to 1 by y first, so that y tends to 0, because it is very difficult to tackle infinity. So, you will write, we will replace x by 1 by y. So, when x tends to infinity, y will tend to 0. So, I am writing this as limit y tends to 0 sin x by x. So, this is y sin 1 by y. X is replaced by 1 by y. So, x tends to infinity means y tends to 0. Now, that should be calculated. It is very difficult to calculate this. But if you think one thing, that sin theta or sin x is always less than equal to 1. This part is always less than equal to 1. So, that part is finite. So, this is equal to 0 into a finite quantity, the result is 0. This sin x or cos x, but you cannot say about tan x. Perhaps in the next problem we have considered tan x. You cannot conclude for tan x, that argument does not follow for tan x or cot x or sec x or cosec x. That argument only is applicable for sine and cosine functions. Since this, whatever be the argument of sine or cosine, that is always less than equal to 1. So, this is less than equal to 1. If it is greater than 1, you cannot write it, because 0 into a greater than 1 quantity may not be 0. Greater than 1 quantity may be infinity also. 0 into infinity is not 0. So, the result is 0. Without detailed calculation, we can write it. The result is 0. So, the correct option will be B. It exists and the value, the exact value is 0. And just one problem of 2 marks. Here we have considered sine x tends to infinity. Here we also consider x tends to infinity, but sine has been replaced by tan. I am writing like this: limit x tends to infinity x tan 1 by x. I have written like this, x tan 1 by x, and that is equal to, if you write x equal to 1 by y, which I have told previously, when x tends to infinity you write x equal to 1 by y. So, this will be equal to limit y tends to 0. You see, this will be tan y by y. Tan 1 by x is tan y and x is 1 by y. And there is a very simple formula like this, the result will be 1. Y by tan y or tan y by y, limit y tends to 0 will be equal to 1. And the next problem, these problems are not very lengthy. You consider the next problem, that is 2 to the power n plus 1 plus 3 to the power n plus 1 by 2 to the power n plus 3 to the power n. Actually, before solving this problem, I can write x tends to 0 if mod x is less than 1. Of course, limit n tends to infinity. You remember this, limit n tends to infinity x to the power n tends to 0 if mod x less than 1. So, try to make the argument as less than 1. So, from the first one we take 3 to the power n plus 1 as common. Why 3 to the power n plus 1? I am discussing later on. If you take 3 to the power n plus 1 as common, you see this will be 2 by 3 to the power n plus 1 plus 1, and you see that is less than 1, 2 by 3. You have to make the argument less than 1. And in the denominator part, you take, so we have taken here 3 to the power n plus 1 as common, 3 to the power n plus 1 as common. So, in this part you take 3 to the power n as common, and the result will be 2 by 3 to the power n plus 1. Without any calculation, you know this part is 0, this part is also 0. So, the result will be 3 to the power n plus 1 by 3 to the power n, the result will be 3 only. Without detailed calculation, we can say like this. So, in the next discussion, we will go to the next subtopic, that is continuity. Actually, continuity and limit, they are very much correlated. So, how the correlation is there, I will discuss in the next presentation.